I'm Louis from the R&D IoT team, and so we'll talk about how to integrate hardware with Odoo, and this is done by using an IoT box. So you can scan the QR code for to prepare your questions for later. So I don't know how much time I should let it, but let's see. So first, let's talk about integration methods. So in which case you should use an IoT box, and in which cases you shouldn't. And so you should use an IoT box when there is no other integration method possible. So there are devices that have communication protocols that are non-native for browsers. So you know that Odoo runs inside of a browser. And so if you don't have an API, and if you need to go through USB or serial ports, so you will need an IoT box. You will also need an IoT box if you need automated printing, and if you want plug-and-play devices. So this is the case, for example, for kiosks that run with IoT boxes. So there is a big disclaimer here. So you should try to avoid the maximum using the IoT box, because we use the IoT box only because we have to integrate some devices that we can't do other way. So if you have a device that has an API, we use cloud API devices like the pricer tags you see in supermarkets. If you have this kind of integration, you should do this, because the IoT box will add an additional layer of complexity. So you will have network configurations, and so it's a lot more code. So yeah, we all know that if we increase the code surface, then we increase the number of bugs, and we also increase the security issues, the potential security issues. So if you can avoid this, just avoid it. So now, if you have no other solution, then you need to understand the software architecture. And so you need to know that the IoT box is a Raspberry Pi. So so it's just a Linux computer. So it runs a Linux distribution. And this Linux distribution, we provide it to you. We customize Debian version, and we deploy the versions on Odoo nightly. So always use the latest version of the IoT box we provide. So the last one for now is the 25.07, which corresponds to the year and the month we deployed the image. And you should note some things if you have to update some system configurations. So you have to note that /etc/var and /tmp are temp file systems. So that means that these are created on boot, and these are deleted when you reboot. So this is meant to reduce the amount of writing that are on the SD card. You probably won't have to deal with that, but if you have to do, then you need to know. And the second part is the Odoo code. So there is a service that runs on the IoT box, which is odoo.service, and that runs an audio module from the path /home/pi/odoo, and that's technical details, but you need to know that we don't have all modules, so that's the sparse checkout thing, and you don't have the whole Git history, so you won't be able to switch between branches, and so when we update the code, we just fetch and reset, so you can't manage branches with this kind of clone of Odoo on the IoT box. Now talking more about the service architecture, and this is more things about you will need to deal with. So it's split in two main parts. So the first one is the core, and the second one is the IoT handlers. And the IoT handlers are the interfaces and the drivers. Interfaces and drivers are created to deal with devices directly. So these are threads. You have one thread per interface, and so an interface corresponds to a type of device. So to understand more, if you need to use serial devices, you will have an interface that will run continuously and try to detect if new serial devices are plugged in. So you'll have one for serial devices, one for USB, one for network, and so on. And then once the devices are detected, these interfaces will also filter the one you want to support, because you can detect multiple devices, but you might only want to support one brand or one type of device. You'll see by yourself. And when it's the interface detected, the interface detected the device, you will need to communicate with the device, and that's what drivers are meant to. Drivers are other threads, and you have one thread per device plugged in. So if you have two printers, you will have two drivers. If you have two printers and a black box, for example, in Belgium, you'll have 3 drivers. So this is where you declare the actions that are available from the database, and it handles the communication with the physical devices. The first part that I didn't talk about is the core part, and this part is meant to, it's like the main thread. It's meant to run the code, start the interfaces, start the drivers, ensure that the service is up to date. So you have to know that the Odoo service updates depending on the database version. So if your database runs SAS 18.4, your IoT box will be in SAS 18.4. If it runs 17, your IoT box will be in version 17. And it will also download the handlers from the database, so the interface and the drivers. To understand, the IoT box is provided by default with some drivers and interface that come from the module IoT drivers in the in Odoo community. But if you define new drivers and new interfaces in other modules that are installed in your database, they will be downloaded on the IoT box. So this is the way to write new drivers. You will have to create a new folder in your module, which is called IoT handlers. And inside of this, you will have 2 folders, which are drivers and interfaces. And here you'll place your drivers and your interfaces, and I'll show you later how to write them. And so the core, just to say it also, it shares the devices that are plugged to the database so that you have the records in your IoT app. And it also receives actions and sends events, like it directs it through the right driver and so on. So the first thing you want to do if you want to write a new driver and a new interface, so if you want to do a new integration, basically, you will have to write an interface. So you'll create a class that you will put in your IoT handlers/interface in your module, and you will make it inherit from the interface class. In here, you will define the connection type, and then you'll override the getDevices method. This is how the IoT service will know that a new device has been detected. So in this method, you only need to return a dictionary with the name of the device and the identifier, which should be unique because it will be the identifier used in the database. You can provide everything you need in this dictionary. The 2 required are the name and the identifier. The next step is to declare a new driver, and you will make it inherit from the driver class. In this one, you will be able to get what you put in the previous slide in the dictionary you returned. So that's why you can put everything you need here. And here you'll define what you need to interact with the device. The previous one was to detect the device, and this one is to interact with the device. So you'll declare the actions available in the action dictionary, and then declare the method associated. There are 2 ways of returning data on an action. So this is the old way. So the old way is to provide data in the data dictionary under the result key, and the new way is to return directly a dictionary. Once you call an action from the database, it will find the action name from the action dictionary, call the associated method, and then return the value to the database. And the return of the value is done by registering an event. And you should know that once you register your action, if you call it, it automatically registers an event. So you don't need to do it yourself. Now from the database, you want to send actions to your devices, and so the easy way is from JavaScript to use the IoT HTTP service, from which you only have to provide the ID of the record from the database, the identifier that you previously set on your device, and then the data you want to pass. So the action name and the value that you want to provide, and this value is the parameters you will provide to the action, to the method. And then here you can also define the callbacks. So one callback for the success, and one callback for the failure. So if the action fails, it will call the second callback, and if it succeeds, it will call the first callback. You should know that these services will try 3 protocols. The first one, and the historical one, is the long polling. So it's 2 HTTP requests, which are one for the action and one for the event. You send an action, you say, yeah, do this, and the device will do it. And the second one will be a second request to say, hey, do you have an answer for the action that I sent before? So this is the long polling principle. But this requires to have a perfect network configuration. So what we do is we have fallbacks. And so the other ones are webRTC and WebSocket. I didn't told you in the right order, but the first one, which is tried, is the webRTC, which will try to establish some kind of a WebSocket connection between your browser and the IoT box without going outside the network. The second one is the long polling that I just explained, and the third one is the WebSocket connection. So the WebSocket connection will just be like your browser is connected to odoo.com, your IoT box is connected to odoo.com, and then you send messages, you can read the responses. But this is technical, and you don't need to know that. You use the service, it will do it for you. You should know that if you try to make an HTTP request from the database, it will not work because it's not on the same it's not on the same network as your IoT box. So don't try to do a request.post or request.get from the database. This is only doable from the front end, so from the JavaScript, because your browser is should be on the same network as the IoT box. So if you have to send a request from the backend, just use the WebSocket, and this is done by calling on the IoT channel model, you have to call the send message method. So you'll find plenty of examples in the code base, but basically you have to provide the identifier of the IoT box, the identifier of the device, and the data you want to pass. Now, if you want to debug the IoT box, this is a very important part, and I should give you some tips, and the first one is that you can find the IoT box logs in the database because they are sent by batches every 5 or 10 seconds, something like this, and it's sent to the database. So you'll find that in your logs, you'll find the IoT box and then record the number of the record, the ID of the record, sent this log, and you'll find it written under. Now that you can connect to your IoT box using SSH, if you're on the same network, it's easy. You just SSH on the Pi user on the IoT box IP address. And if you're not on the same network, you can provide your clients a remote debug token, which is an ngrok token. You provide them that, so they can do it from the IoT box homepage. But now it's new in v19. You can provide it directly from the database. So if you go to the IoT Box app in debug mode, then you will be able to click on the remote debug button, and you'll be asked to provide the token. So you can do it for your clients. Once you're connected using SSH on the IoT box, you have a few aliases to debug, which are restarting the service, show the logs, show the configuration. You can change the branch if the IoT box didn't update correctly. And you can also use some dev tools, which are, so you have two. The first one is general, and the second is actions. So actions is meant to enable or disable specific actions. So if you want to test things but not print every time, like test printers but not print every time you want to make a test, you can just disable the print receipt method or stuff like this. And the general one is to disable the download of the IoT handlers. So if you disable it, it will only keep the old drivers that it has and not download the new one from the database. And if you disable general, you will also disable the update of the IoT box. So if it's in V18 and you have a database in V19, but you don't want your IoT box to check out V19, then it will not check out if you disable general. Then you have more aliases to help you, but just type Odoo help and you'll see. Thank you for listening to this, and if you have questions, then you can just ask them.
So thank you for the presentation.
Yeah.
Are there any plans to integrate with LoRaWAN devices?
Can I see the name?
LoRaWAN.
I have no idea what this brand is, but yeah, if the integration is through the IoT box, we're not planning on integrating much because our goal is to integrate the minimum possible with the IoT box. So if we integrate new things, it will more likely be from the database directly. So devices with API enabled, as I said.
Why only one payment gateway per IoT box?
One payment gateway. I'm not sure about this one, but I think it's just a limitation from the IoT box. I think I'm not sure.
Is it possible to integrate custom devices with like custom drivers on the IoT box?
Yeah. So as I explained, I think this has been answered here. So yeah, you write your interfaces and drivers. You put them in your modules, and if they are installed on the database, then when your IoT box is connected to this database, it will download it from your database.
What about virtual IoT box in a VM?
I think this question is about Windows servers. It's possible. I think it's possible. I know it's possible. So yeah, just use a Windows server, and yeah, it should be working.
Is it possible? No. Is there any maximum for each IoT box devices? Is there any maximum for each IoT box for devices?
Is there a maximum device we can connect to an IoT box? So there will be a limitation depending on the number of USB ports on the IoT box, obviously. But if the devices are network devices, there is theoretically no limitation.
Or can we use webRTC to reply back to box?
Yeah, just so if you use the IoT HTTP service, you don't have to worry about what protocol it uses. You just call the IoT HTTP service.action, and it will try the webRTC. If it fails, it will try the long polling, and if it fails, it will try the WebSocket. And but if it succeeds, then you will receive the answer yourself. You don't need to worry about how to get the answer. It will call the callback itself.
We have 6 cash registers with 6 card payment terminals with 6 IoT box. Is it better to use for each device one IoT box?
You said that there were one payment terminal per IoT box, right?
They have one. Yes, they have one payment terminal, related to one cache register
Yeah.
linked with one IoT box.
So
Is it better
the
to
limitation here is the number of payment terminals per IoT box. So if your payment terminal needs IoT integration, then you will be limited by that. You can have only one payment terminal per IoT box. So yeah, in this case, the answer is yes.
Odoo restricts IoT box for only one device because it finds more than 20 devices which I do not need. If I connect to 2 or more IoT box to the network, they don't have the same number of devices.
So this has been fixed recently. So the thing was, the goal was not to duplicate the network devices, because if you have 2 IoT boxes on the same network and it finds, the first one will find all the printers, but if the second one finds also these printers, imagine you want to select a printer from the point of sale, then you will see 40 devices instead of 20, but the reality is that on the network there are only 20. So this was the reason why we limited that. But as it was causing incomprehensions for a lot of people, we decided to just display all the devices on all IoT boxes. So on V19 you won't have this problem anymore. I think it's been merged before. So even in starting as of V16, it should already be.
When I use my own IoT devices, do I have to pay for a subscription module? For a subscription. When I use my own IoT box device, do I have to pay for subscription?
The thing is, you have the physical IoT box is paid and the virtual IoT box is free, but it doesn't matter if you bought it yourself or if you bought it through Odoo. The subscription depends on the number of IoT box connected to the database. So it's just counting the IoT boxes on the database and making a difference between Windows and Linux IoT boxes.
So the answer is yes.
Yeah. Yes. Sorry. This you should connect to your router's interface, and you check for a static DHCP record, and you can set you can find your IoT box by its MAC address on your network, and then you set the IP address, and it will be fixed every time the router will give it the same IP address. Just do it from your router.
Okay, just the last questions. Very interesting one. Is the IoT box really reliable to connect a black box in my restaurant? I have heard some bugs.
Yeah.
So after. Just I'm giving a context.
Sorry.
After Odoo migration for V15 to V18 Enterprise, IoT box stops working. If I install a new image, will it resolve the problem?
Yeah, it's very probable that your IoT box. So between V15 and V19, we might have released like 10 new images. I'm not sure of the number, but yeah, just start by flashing the new version and pair it again with the database. The echoes you've heard for the black box and the point of sale, yeah, it's true. And so recently we have the multiple bugs, and we fixed a lot, and it is a lot more stable now. There are lots of issues still coming from poor cables provided by the black box provider. So. I think you can just, if you still have problems with the cable, just contact the support and we'll help you with the cables.
Thank you very much.